Welcome to another edition of Math for No Reason. In this edition, we are trying to evaluate this integral from 0 to 100 of the floor of x dx. Floor of x is also sometimes called box x, and this is same as this. In some books and papers you see that this will be written as in this manner, and this is nothing but the greatest integer less than or equal to x. So if x is 1.6, box x is equal to 1. If x is 39.4, box is equal to 39, and so on. Now to evaluate this integral, we will be using the linearity property of the integral. So we will be breaking up this as integral 0 to 1 box x dx plus integral 1 to 2 box x dx, and right up to integral 99 to 100 box x dx. Now why we have done that? We have done that because we know that box of x is constant in these intervals except at the right end point. So if you look at the graph of box x, so the graph of box x in this interval will look like, so between 0 and 1 it is 0, between 1 and 2 it takes the value 1, between 2 and 3 it takes the value 2, and between 3 and 4 it takes the value 3, and so on. The point to note here is that there is a jump in the function value at each of these integer points. So the function is right continuous at these points but is not left continuous. The function is not a continuous function. Now keeping this in mind, we will write this integral as integral 0 to 1 0 dx plus integral 1 to 2 1 dx, etc. integral 99 to 100 99 dx. Now you may object that, well, at the point 1 the function value is 1 and not 0. Will that be a problem? The answer is no, that will not be a problem, because in the case of Riemann integral, if you change the value of the function at a finite number of points, then the integral is not changed. So the modified function will have the same integral as the original function. So therefore, if we modify this value at the point 1 to 0, nothing actually changes in terms of the integral. The function changes, but in terms of the integral, nothing changes. So therefore, this becomes 0 plus 1 from integral 1 to 2 dx, and so on, and this term is integral. Now from the theory of definite integrals, we know that the integral of dx is x, and we will evaluate it at the point 1 and 2, and to get to the value we have to first find the value at the upper point, which is 2 here, and subtract the value at the lower point, which is 1 here. This is known as the fundamental theorem of calculus. This will simplify as, and this is nothing but the sum of the first 99 natural numbers, and we know that the answer is n into n plus 1 by 2, where n is 99, and this gives us 99 into 50, which is 495. Thank you.